And we are live. How's everybody doing today? Really hope you're doing well. Hey Plain Truth, good to see you. Hey Kiki's Seabass, good to see you. And hey Jack of all trades, thank you for all joining. Yes, I left the poll today. Sorry, I left the poll today so we can see how much people actually like reaction comments. Out of 4 votes so far, we have 75% yes and 20% it's okay. Okay, so it's gone up to 80% yes and it's okay 20% because it's 5 votes. Anyway, how's it all doing? I hope you're all doing well. I hope the sound's doing okay. The lighting, I hope, is fine. As you can see, I'm just changed it around because I realized yesterday after the stream, because the sun is coming and lighting up the background too much, you can't even see me after a while. So I decided, let me do a 180 degree and yeah, let the sunlight come to me. In other words, yeah, Plain Truth, it's a dating stream. You want me to set you up with someone? 12 a.m. there. It is now by me 2 minutes to 6 in the morning. Hi Nos, how you doing? Good. I hope you're doing well, dude. Yeah, so even yesterday I had to do an early stream because with this load shedding schedule it really messes everything haywire, so I couldn't do a night stream last night. I had to do it yesterday morning, but it's fine, it's how it's going. Yeah, so I'm doing the morning stream today and then just have to give news for next week because I've got family coming over for my daughter's birthday and everything. I'm only going to do a Wednesday evening Discord stream, and I think it would be the Sunday morning stream, not the Saturday, but I'll let you guys know Wednesday which one it is I'm doing. I think it's just the Sunday, not the Saturday. Yeah, 2 p.m. there, that's quite cool. Yeah, 4 people doing. Thank you everybody for coming. Please just don't forget to hit that like button. It really helps the boops so I can get to more people. Maybe I'll go out to great. Good to see you guys. If you guys didn't know, I do now have a gilded room as well. Started that yesterday as well, so the link is in the description box if anybody's interested in joining the Discord or even the gilded, because I'm going to start having streaming there as well once we've got enough people in there. I have so much comments. If I had to actually place all the comments of what I did, screenshots and stuff, I would still be sitting another hour or something just plonking them in there. So I just randomly just took some and I just stuck them on so we can go through some of them, because yeah, most of the comments we do get, I think most of the people realize from the flat earth side, is the comments you get from the globe earth trying to defend it is usually contradictory, or it goes totally against what the definition of that is that you're talking about. So yeah, but that's practically what is going on. So we can just go through some of the comments together and we can see how should you react to something like that, especially if a lot of them just contradict each other and what we observe. But yeah, oh, I haven't done that yet. Shout out to all my patrons. Shout out to Kiki's Seabass. Shout out to Michael Khan, and shout out to Skeptic926 for becoming a Rooster Den Patreon. You guys rock. And thank you Aaron Armstrong for being the Wolfpack Patreon member. Your guys' support really does help this channel and I really do appreciate it. And thank you to everybody that's been helping me with super chats through the last week. It's really getting great. Thank you guys. So yeah, you guys must try and maybe help me think of an idea to shout out the super chats and super thanks a bit more better, because at the moment all I'm doing is really saying thank you guys, you know, like yesterday, well, the first one was Nathan Oakley, but it was a premiere so I couldn't shout him out, so I had to shout him out yesterday. And then yesterday I got Colin Ferguson, I think, and I know Wesley Eastman or something. So I just had to shout them the whole time. So yeah, really awesome. So far we got 57% of people saying yes. We even get a 14% saying no, they do not like comment reaction videos, which I understand you get some of them that don't like it. It's good to see there's at least 8 people in so early. Hopefully it will start growing later on in the stream. So I was thinking we can go through some of the things, maybe just go and check. So if you guys want to get started on the comment section, I'm more than happy. Otherwise we can just have a little bit of a chat still and go on like that. Just let me know. Yeah, okay, I think if you guys want me to start with comments, type 1 in comment section. If you want me to talk a bit more about until we just wait for a bit longer, type 2. Yeah, comment section reaction is interesting. I 100% agree, because it kind of brings out the information in another way. Because a lot of times you can't really react to it how you intend to when you're typing, and they can't really see the engagement, I say. Hey Colin Dresser, good to see you, thank you for coming, and it's entertaining, 100% agree. Okay, so far we got 1-1, so far that's a yes to start the comments. Hello to all the new people that came in. Okay, so I think I'm going to take it as a yes, because logical observations. How's it, logical observation? Thank you for joining. Okay, let's get started. I'm sure there's going to be more ones probably. Let's go to this. I have to see if it's showing. Yes, it's showing. Okay. So we kick this one off with Professor Phil Bell. This guy, he really comes and gives quite a few comments, and a lot of them he doesn't understand how he's contradicting himself. But yeah, like I said, I just took a whole bunch of random ones because I have so much screenshots on my phone. I didn't even really check which ones. I just cropped them out and stuck them in so we can go through them. First one, Professor Phil Bell. So your imaginary friend Mike has never stood on top of something not horizontal. How about the top of a mountain? What if you hung a plumb bob from a slanted ceiling or beam? Okay, now this is really interesting because you have to understand the context of this. This was taken from about how a sextant works. So obviously a sextant requires a horizontal. Now he's saying you don't have a horizontal if you're standing on a mountain or something. Little does he know, Professor Phil, I thought you're a professor. What does plumb mean? Does it not mean a vertical? Does it not mean 90 degrees to a horizontal? This means you are hanging a plumb bob to have your vertical, so you have your zenith. So you can have an elevation angle across a horizontal plane. And as we know, when you use a sextant, it has to be parallel with the horizontal. In other words, that's why when you guys have to make your dip correction, so you have it's sitting actually horizontal on 0 degrees, mean sea level. That's why it happened, because how a sextant works, it has to align perfectly. Those rays coming in have to align perfectly with the index arm horizontal. Because remember, the index arm has a arc. That is the measurement reading, the arc measurement reading that is actually translated from the sky. It has to be parallel. That's why they say you use the horizon. So when you're creating an artificial horizon or standing on a mountain, you're creating using a plumb bob, you're automatically creating that horizontal plane, which is parallel to the horizontal mean sea level. I thought that very interesting. Stasis in spaces. I haven't seen this guy for a while. This statement is absolutely correct. You do not need a horizontal to measure an angle from a vertical. But a vertical in Plumb requires a horizontal, otherwise it's not 90 degrees. And from the measured zenith angle, you can precisely calculate the elevation angle, so the horizontal is simply not needed. How much contradictions can you have in one statement? Yeah. Okay. First contradiction. A vertical and from the measured zenith. The zenith is the vertical. You cannot have a zenith vertical angle without having a horizontal. And the elevation angle is across the horizontal. So you require horizontal because the elevation is a horizontal. Yes, it goes across the horizontal. That's why you have co-altitude angle, because you're zenith, and you have your elevation angle, which is over your horizontal. Yeah, very, very interesting indeed. Pirate guy, this guy still hounds me a lot. So the angle is measured from the ground. Yes. Last time I saw you are physically standing on something, be it a boat, a mountain, a floor, grass, sand. It's physical, is it not? People lay down to operate the sextant. No, people don't lay down. They simply make the angle to the 0 degree baseline, the deck, the 180 degree deck, which would be 0 degrees, obviously. So that's why you do your height of eye correction, which is your dip correction, because your eyes or the sextant, the scope, is not embedded into the ground. You are standing with it, and you are bringing that sun or whatever you've done brown to touch the horizon. Why do you do that? Because you have to align it horizontally. You have to align it with the horizontal horizon. That's what horizon means. I just want to check on ooh, wrong one. I just want to check on how the comments going. How are you guys doing? Thanks everyone else for coming in. Hey someone, good to see you. Colin Dresser, Gracious Calf, thank you for coming. Yeah, it's already quite contradictory in statements, guys, don't you think? Mac 65, good to see you. Glad you could make it. Gracious Calf, don't you always use the horizon with the sextant though? Yes, Gracious Calf, you always use the horizon. That's why when you're on a boat and you do not see, let's say, the horizon because it's a foggy day or something, you create an artificial horizon. That's the whole reason for the artificial horizon, because you require a horizontal baseline. The mechanics of a sextant means it has to be perpendicular to the vertical, which means it has to have a horizontal. That scope has to sit horizontally perpendicular to vertical. Otherwise, it's not going to work. You cannot take an altitude angle measurement. It has to have parallel rays. It has to be parallel to the ground, to the horizon. That's why. That's why you do dip correction, and that's why you do need horizon. So when you get hey Skeptic 936, welcome. He's one of the Patreons. Really do appreciate you guys. Thank you for coming. And Sean Hawkins already saying I got so much wrong already. Okay, Sean, don't worry. I'm still going to actually show you on the stream the mechanics of a sextant, because you guys simply do not understand it works with angles. Okay, so yeah, you do need a horizon. When it comes to a bubble sextant, it's creating a horizon, an artificial horizon. Why? Because it needs to be horizontal to the horizon, mean sea level. Also, if you're in a plane, what happens to the apparent horizon? You've pushed it out further, so it is rising relative to eye level because of perspective. Okay, jack of all trades, flats. Will you ever grasp treating the horizontal as 0? It's simply convention, simply the math, and set to any number between 0 and 360 simplifies the math. Jack of all trades, are you trying to tell me that 0 degrees does not exist? Are you trying to throw math away now? Because 0 degrees means no curve of globe. Seems to me that way, guys. Okay, Grayskull, show us the landfall navigation sextant manual. Page 9, about dip correction. Landfall navigation sextant manual. Copy. Yeah, let's get it. Landfall navigation. Wow. Okay, let's go to page 9, he says. Make sure it's there. Is it showing? Yes, okay. To adjust the beam converger, the horizon mirror. You know what a beam converger is, Gracious Golf? You know why it's called a beam converger? Because it has to converge. Adjust the side mirror by making beam converger perpendicular to the frame. You know what frame this would be? I'm going to explain it to you when I show the sextant stuff on here, how it has to align. I mean, it has to be perfectly perpendicular. In other words, a vertical and a horizontal have to be perpendicular. You're already making my point. Holding the sextant and your right hand, raise the instrument to your eye. I raise it to my eye. Look at any horizontal straight edge. See the horizon or the roof of a building. Yes, because the horizon is the apparent position where the sky and the earth appear to meet. So in other words, a roof can be a horizon. It's still horizontal. Okay? And move the index arm back and forth using the quick release levers. So in other words, when you got it, you're holding, you're just moving the index arm. You're not, because you're just trying to see if it's aligned. So when you, let's say, look at the sun, you're looking up. You're not going to be moving the index arm because that has to stay horizontal. You're going to just click it so it stays like this while you move the sun or whatever down to touch the horizon. That's why you have an angle measurement, the arc. But I'll try and explain it better later. Line up the reflected horizon with the real horizon, with a knob that says both appear together in a single straight line. Nice. So you're aligning horizons. Without changing the setting, go through the sextant at any vertical line. A flagpole on the edge of a building, for example, and slowly tighten or loosen the screw closest to the frame at the back of the beam. The converger. Until the real and reflected vertical lines perfectly coincide. Excuse me. This is practically easy since the two images have different colors. It is simply a matter of putting one image exactly on top of the other. Yeah, because why? This is why you need it to be perfectly perpendicular, because you have to align them so it can be horizontal. Because why? A sextant works with horizontal baselines. So, well, that was page 7. I thought it was page 9. But yeah, it says page 9. Okay, that would be page 8 then. Ah, okay, so this is the one. Sorry, because I saw their page, so my mistake. Grayscale. Let's go on to here. Correcting for height of the eye. When measuring the altitude of the sun, like I was saying, you need to measure the angle formed by a ray from the sun and a plane tangent to Earth at a point. Okay, so that's what you guys are saying, because you are looking down to Earth, you require a tangent. And you know what a tangent is? A straight line meeting at a point on a curved surface. Okay, where the observer is standing. However, due to the height of the eye, the observer, the visible horizon actually falls below this theoretical place. What theoretical place is he talking about? Would that be the tangent? This requires the dip correction to be made. Due to the height of eye of the observer, the visible horizon, remember horizon, visible means it's apparent, you can actually see it. Yes. What is horizon? It's a horizontal plane, flat, level. Falls below the plane tangent to Earth at the point where the observer is standing. Remember they just said that plane tangent is a theoretical place. Had to point it out again. To apply dip correction for the height of eye, apply a correction as shown in the table below. Dip correction increases as the eye is raised further above the surface of water. And everybody knows water lays level. Water at rest is level, which means flat, horizontal. If your height of eye is 5 feet off the ground, that's 1.5 meters, that's about a normal person about, you do a 2 degree dip correction, and it goes on and on. This is exactly the same on a horizontal plane, on a flat earth. Just because you want to make a figure with a theoretical place called a tangent to say the ground is curved underneath doesn't make it a curved surface. You still require height of eye correction, because if I'm standing in my lounge and I'm looking down, my eyes are not embedded in the ground. That is the dip of correction I have to make. That 2 degrees is the dip of correction I have to make, or 2 minutes, because I'm not, how can I put it, my sextant or my eyes are not, as I said, embedded in the ground. That's why. You could do this. I can take this out and draw a donut. I can take this out and put a triangle if I wanted. Because why? I did a measurement on a horizontal. How do I put this? I did a measurement of the horizontal, and the height of I is what? Parallel to the horizon. That's why once you've made your measurement, you do dip correction, which is height of I correction. After you've done what? You've already done your measurement. You've got your elevation angle already. That's why you got a sextant correction. You got HO and you got and all that for that reason. Very simple stuff. But thank you for bringing this up. It just shows you want to rather look at this, and because it's a theoretical place after you've done your measurement on a flat baseline, you think therefore globe. No, I can erase this globe and I can put a diamond if I wanted to. I can put a flippin' pyramid. Doesn't matter. You will always be height above, and you will always have your height of I parallel. That's why when you align your sextant, it has to be parallel to the horizon. That's why you bring the sun down to touch the horizon. So yeah, I hope I've made that clear to you, gracious Colf. Patrick Shank, good to see you. Thank you for coming down. Good to see everybody here. 15 people, it's getting there. Gracious Colf, please keep the diagram screen longer. It just shows you will deny sextant. No, I don't deny anything with the sextant manual. I just show you that reality, gracious Colf. Because your narrative of your globe is there's a globe, they obviously have to draw a globe in there. But the reality of the mechanics is it's based off a horizontal plane. The mechanics of a sextant cannot work if it's not parallel. It cannot work if the sunlight is not parallel, the stars are not parallel. It cannot work if your horizontal baseline is not parallel to the perpendicular to the vertical. It cannot work if your sextant is not parallel to the horizon. That's how a sextant works. It's the mechanics of the sextant, gracious Colf. Citizen Z, good to see you. Glad you could make it. Glad you could make it. Thank you for coming. Make 65 plats. I don't know why you're bothering with these 2D people on a 2D ball. I 100% agree, dude. Actually, I do, because I feel sorry for them. I feel pity for these guys because they sit in some kind of cognitive loop where they just have to go on and they don't understand what's going on. That's unfortunate. Yeah. So then again, yeah. Let's see what the poll says. Do you like comment reaction videos? Out of 18 votes, 67 people say yes, 11 people say no, and 22% of people say it's okay. Great. What would be fun about something if life we all had exactly the same opinions? Citizen Z, at Sean Hawkins, parallel to the plane of the horizon. Exactly. At right angles to the vertical, a horizontal line. Exactly the point I'm trying to make, Citizen Z. Very, very true. It's weird how they want to take that, so much horizontals, and say it's curving. Should we go on with the comment section, guys? And please don't feel shy to give a super chat. It really, really does help. You guys are awesome. Okay, let's get to it. First have to find... And is it showing? Yes, it's showing. Okay. So we saw this one already. Lay down to sextant. And Aaron Armstrong, again, thank you for being one of the Patreon supporters. Do really, really appreciate it. Can't hang a plumb bob in a staircase. Again, the context of this is, what happens when you hang a plumb bob? Can you hang it in free space? No. You literally need it to point downwards. So that means it's always a vertical. A vertical to what? To a horizontal plane. So it doesn't matter if you go up a mountain, if you go stand on the side of the staircase, if you go stand on a car's roof or bonnet, or if you're trying to hang something, it's always going to... Oh shit. What just happened? Oh, sorry. I hope it's still showing. Is it still showing? Okay. Let's take this. Let's try. Oh wait, I can't turn. Why? Because it's staying vertical. It's denser than the air, so it's going to stay vertical. Doesn't matter where I'm putting it. It's always going to vertical. It falls vertical. This means plumb, 90 degrees to horizontal. Okay, so nonsensical that. Daryl Kimmel, I haven't seen this. I think he's got quite a few soccer counts on the other. At flat source perspective, it only requires a vertical zenith to measure the angle from the star, angle to the star from the zenith angle. Subtracting the angle of altitude from 90 degrees. Let's go through this again. It only requires a vertical zenith to measure the angle from the star, from the zenith angle. What is the zenith angle? It falls across the horizontal plane. Yes, because you are 90 degrees. This is your zenith angle, which is 90 degrees. So if you subtract an angle of altitude from 90 degrees, what's a 90 degree angle, Daryl? Would that be perpendicular to a 180? Ouch. Or a 0? Yeah, kind of contradicting yourself there. You only need the zenith angle, but you just said you have to subtract from 90 degrees, which requires two lines. That's what a zenith angle is, 90 degrees. So it's a horizontal, well, vertical to horizontal. Yeah, look at the timestamps of the videos to see the geometry that does not need a horizontal. I've been trying to explain this to these guys. I don't even know, it makes my brain hurt how much times. A 90 degree cannot exist if it hasn't had a 180 degree. It needs a 180 degree or 0 degree. It's a horizontal baseline. Without the horizontal, you cannot have the vertical. Without the vertical, you cannot have the horizontal. You understand? They are together. There's no such thing as just a vertical without a horizontal in reality. Because when you hang a plumb bob, there's ground somewhere. Doesn't matter what altitude you are, which angle you're standing at, there's ground. It's horizontal. If you're standing somewhere on the ground, there has to be a vertical somewhere because you are always vertical. You can try to stand like this, it doesn't mean you're still not vertical. Understand? It's very, very simple, guys. This is stuff you learn in primary school. I think I was 6 or 7 when I started learning this stuff. Brett G. Flat source perspective. There are two lines. Great. Are those lines straight? Straight lines, rays? And a vertex at the sextant. At the sextant. Okay, so meaning the sextant is probably the vertex point. Okay. And neither of those lines is perpendicular to the vertical at the vertex. You know the horizontal baseline when using a sextant is perpendicular to the vertical and it's parallel to the horizon. Yet there is still a measurable angle. Yes, because you have a perpendicular. Your whole sextant is set up perpendicular. Remember, we just showed that in the manual that Gracious Carl so kindly told us to go look at. Yet there is a measurable angle that between those two lines. That angle is also, that angle also isn't an elevation angle. You just measured an elevation angle, so that means it is an elevation angle. That's what an elevation angle is. It's the altitude angle, the apparent altitude angle of the star, whatever, across the horizontal plane. Your understanding of the angle seems to be really wrong. Yes, Brecci, that kind of means you got, how can I put it, you projected, because your whole statement contradicts what an angle is. I mean, you are explaining through and through how angles do work on a sextant while saying it doesn't work that way. Oh man. Aaron Armstrong, $5 super chat. Really, really do appreciate, guys. Aaron Armstrong. Okay, let's see. If Keith and FE had said you can't hang a plumb bob in a staircase, I was simply questioning why it's not possible. I said you can hang a plumb bob in the staircase. I just explained why, because it has to go down. Doesn't matter if you're standing sideways or whatever, because it's denser, it's hanging, it's going to go show a vertical, and a vertical plumb is always 90 degrees to a horizontal. So it doesn't matter if you're standing on top of a mountain, on top of a bus, on the side of a mountain. Well, doesn't you know what I'm saying? It doesn't matter where you stand. You cannot hang a plumb bob in free space, because then there won't be any up and down. A plumb bob simply shows down. So yeah, thank you for the super chat, Aaron. I hope it makes sense to you now. I don't know if I must try and explain it differently. That's kind of just how it works, yeah. So thank you again for your super chat. Really do appreciate your support, guys. Aaron Armstrong is really a great patron and supporter of this channel, so I have the utmost respect for him. Okay, I think let's go on to some more comments. I have so much. It's insane. Like I said, I have so much, and I didn't even put half of them on. I just quickly took randoms and put them on. Got so much. Great Wall of Vacina, or whatever. The surface of Earth isn't one of those lines. The horizon isn't one of those lines. So he's saying the horizon has got nothing to do with the sextant. Also, you're not measuring 90 degrees if you're looking down at the horizon. So how could you possibly measure 90 degrees to a horizon that isn't horizontal with your eyes? This is done before the dip correction, before your height of eye correction. That's why you have your sextant set up at a 90 degrees, because you have to have your sextant at a simple 90 degree angle, perpendicular. So you need perpendicular to have that happening. Let me see if I can quickly find. I think this is going to be quite eye-opening for you, maybe. I don't know. Let's see. It's very simple how this works. Let's put it on mute. Okay, let's go. Let's make sure I am showing. Okay, is it showing now? And it's showing. Okay, I want you to take very close observation on the mechanics here. This is the index arm. It moves around. This index arm moves around the arc. This arc has a horizontal. This horizontal, to have it actually measuring an angle, needs to be horizontal with the horizon. You understand? It needs to be parallel to that. So this ray is parallel to the horizon, and this line, to have your arc measurement, has to be parallel. So you got a parallel, parallel, and a parallel. You get it? Because this... Oh, let's watch some of it and we'll go on. Okay, press clamp to release the index ball. What is going on here? The light rays are traveling through those filters, obviously, into a mirror, which is bouncing through the filter again into a mirror and back to your scope for you to see. But remember, this is the sun that's coming through. So in other words, this is what he sees at the moment. He can't see the sun because he hasn't brought it up. This is what he's seeing now, the horizon just coming through. Parallel, parallel, parallel. It's all just parallel rays. Why? Because he's holding his sextant vertically, perpendicular. Okay, see, he's just moving the index arm so he can get, there's the sun. So they are meeting now at the same parallel. He's holding his sextant on a vertical. See, it gives a reading on the arc. This is the arc reading measurement. This arc reading measurement is an angle, which it can be subtended as the arc in the sky. Why? Because it's based on optical measurement. You're seeing it through a scope. It's perspective that it's sitting at an apparent altitude angle. Obviously, you've got the micrometer, which gives the minutes. Okay, so what's going on? He's setting it. Nice, locked it in position. Nice swing. They're swaying it both the way because they have to, so you can see that it's touching the horizon. This is so you know it's sitting perpendicular. Because if it wasn't giving that arc, it's not going to be sitting perpendicular and you did not have a correct angle measurement. Read the angle. Yes, and that's about it. That was quite a simple one to go on. Did that answer the question for you? I hope that answered the question. Godzilla37, hey, thank you for the super chat, dude. Really do appreciate you. Another super chat, I can't believe it. Can you move to my side of the plane? You're always on so late for me. Have to catch the rest of... Sorry, Godzilla. Usually I do a show in the evenings on a Saturday, which would have been yesterday. But the thing is, because you got load shedding at the moment, it's scheduled power cuts. I had to change it to yesterday morning as well. So I'm so sorry about the Godzilla. I'm still trying to work out the best time for the debate evenings, which I think is going to be in the evenings as well, on a Thursday evening. So really do appreciate your support. Thank you for the super chat. Thank you, Aaron, also for your super chat again. You guys are really awesome. Please do sleep well, Godzilla. Yeah, if you want, you must always let me know if I must do another live stream in the week sometime. I don't mind doing another one for you guys at a different time, just for the guys that are always getting it caught late. So do get back to me on that, and we can maybe hook up and work out another live stream in a week or something for you guys. Patrick Shank. In real life, the horizon is eye level, exactly. But in the globe illustration, the guy has to look down to see the horizon. It doesn't work. No, Godzilla, really, without you guys, I really do appreciate your support. So you do have Discord. Maybe hook me up and we can talk and we can find out a better time and we can have another live stream in the week maybe. I really don't mind. I'll definitely want to have another live stream for you guys. Good night, Godzilla. Good sleep. Thank you again for your super chat. Really do appreciate your support. Exactly, Patrick Shank. So just because the guy stands and he looks down, he thinks the horizon is a physical place. This is what I was trying to explain yesterday with my live stream. If you guys haven't watched it already, please do go and watch the live stream yesterday as we were removing inferior mirage again, which were the 11 frames of the backle. And yeah, by removing that, they're still claiming I removed physical curve. I invited Rhetoric to come and actually chat yesterday while we've been having a back and forth on his channel. What do you think is happening with the guy? Oh, he's running away, making excuses not to come talk. Yeah, Rhetoric 3 years ago says I'm dishonest and I'm taking his earth curve away, and for 3 years he has never really come and actually spoken to me. So I didn't invite him again to come talk. All he's saying to me is, no, it's been debunked and that's it. So yeah, we'll leave it at that. But do go watch the live stream of yesterday. It's really well worth it, with some quite funny things in there, because the contradictions that come out from these globers is really funny. I even had to hop onto Mrs. Google a few times to show them definitions of words, including plumb. Okay, good night. Cheers, Godzilla. Thank you again once again for your super chat. I think we can go on to the... okay, let's see. Is it showing? Yes. Okay. This is from Ken. Question: do you need a horizontal to measure an angle? Answer: no. When it comes to sextant, remember context, people. You require a horizontal. Because why? We live in a three-dimensional world. So you always require a horizontal to have a measurement. If you are on a paper or something and just drawing, you don't need a horizontal because you're drawing it on a piece of paper. It's in free space, you can say, because it's in a two-dimensional reality. We live in 3 dimensions, so you're always going to have a vertical and a horizontal. Full stop. To have a measurement, when you take do construction and you take a measurement to let's say make sure the wall is sitting at a 90-degree, weird, it has to be horizontal. You are on that horizontal plane still making that measurement, because you have to complete the triangle to make those vertical measurements complete. So next question: does a human need a brain to function? Obviously. So they're just throwing an add-on to it after showing you are just really not well up here. That's about it. And there, okay, let's go down. Daryl Kimmel again. At flat source perspective, you only need dip correction when using a marine sextant with optical acquisition of the horizon. Thank you guys. So anytime anybody tells me again, you do not need the horizon when using a marine sextant, which in most cases people do because you are on a boat on the ocean, you require horizontal, your horizon, which is like I've been saying this whole time. Why is he saying you do need it? No one else needs it. Anyway, okay. To base the sighting on the sensible horizon. So, and ultimately establish the zenith and the zenith angle. Your zenith is always 90 degrees. It's not, you're not establishing because of that, but yeah, to have it at 90 degrees, you have to have a horizontal plane. To have a horizontal plane, you're going to require a vertical. They work hand in hand. It's like a square, in other words. It's literally a corner. It's like going to a table corner and saying, sorry, table corner, you're not 90 degrees, even though you are a 90-degree angle. You're just ignoring the one side of that corner. Sextant, let's see, zenith angle. Sextants used with artificial horizons. I wonder why they make artificial horizons if you don't require horizontal. Bubble sextants and theodolites don't need dip correction. No, because when you're in a plane, why are you going to try and work out your dip correction? Remember what I said, you are measuring in a three-dimensional reality. The horizon rises relative to eye level. Doesn't matter how high you are, you always see the horizon in field of view. Yeah, it's going to be kind of dangerous to fly a plane anyway if you can't see anything. But let's say you don't. It creates a horizontal. That horizontal is what? A bubble sextant, that's how it works. It's vertical, horizontal, perpendicular. So you've created horizontal, which is parallel to the horizon, to mean sea level. So, can I make it any more clear? You are actually using the horizon when doing this because it's parallel to the horizon. That's how a sextant works. Brecci again. Flat source perspective. All you have done all day is claim that measuring an angle requires horizontal. Oh, thank you, yes, because it does. Dip correction tells you that neither line is horizontal and that you claim that the angle can't be measured. Do we have to explain this again? Your eyes are not embedded in the ground. You've already taken a measurement angle with the sextant having a horizontal plane without your dip correction. Now to make the measurement more accurate, you take dip correction because your eyes are a height above the ground. We even saw this. We even saw this. What is this, guys? It gives the different corrections for the height of eye. What does height of eye mean? It means the height of eye above the baseline. This comes after your measurement, just so you can correct it to have a better accurate reading. Okay. This one was funny. I just had to throw this one in. Thank you, FT, for being such a great sport. As we all know, he does claim to have been worked in the Navy as a nuclear physicist, but gets the most fundamental things of thermodynamics wrong. We found this out when I actually debated him a few years ago on thermodynamics. That's his perspective. You're so clueless. The math shows it closed. Okay, the math shows it closed, everybody. Okay. The amount of matter leaving and entering is practically the same. He just says it's closed. Remember, this is thermodynamic systems. It's closed. So if it's closed, then how do you have matter leaving? A closed system, you can have energy entering and leaving, but you cannot have matter leaving because it's closed. That's what a closed system in thermodynamics is. Anyway, are practically the same. Physics therefore considers it a closed system, and this is never going to change. Okay, so it's considered closed. It's either closed or it's open. Craig, that's how it works in reality. You either have an open mug, it's an open system, gas can leave in, I can throw my coffee in and I can drink it, or it's closed and I can't get anything through it. Only the energy can go through. So in other words, I can put a heater here and it's going to heat up the gas inside. But then it's closed. Then I can turn around, no liquids are going in and out. That's the simplest form of a thermodynamic system. Open, matter can come in and out. I can throw coffee, I can drink it. Closed, I can't drink nothing because it's staying inside there. Get it? Yeah. Okay. So everyone who does physics is taught the Earth is a closed system. Great. So Earth is taught to be a closed system. Why are you saying that they're better than people? I'm just simply pointing out to you what thermodynamics teaches, Craig. This is something you should have learned if you were a nuclear physicist. If Earth is a closed system, how can you claim satellites and astronauts and everything's leaving this closed system? Yeah, so you should make up your mind. Is Earth a closed system or open system? Because it's taught to be a closed system, yet you want to contradict what thermodynamics is and say it can leave. This is why we say there's so much holes in your guys' globe narrative that it's uncanny. Really, really sad. Let's see. Hey, Jeff Gassett, welcome. Thank you for coming. Really do appreciate it. Hey, Pain Bear, good to see you. Glad you could make it, dude. You guys are really, really awesome. I think I'm gonna go and get a video where I was on the fight of flat Earth of this, because it's short, but it's at least it makes my point. Because Craig doesn't understand thermodynamic systems. He doesn't. He might make you want to believe that he understands it, but I still don't get how you can become a nuclear engineer if you don't even have the basics of a thermodynamic system down. It's sad. Or unless maybe the Royal Navy just doesn't have high standards for nuclear physicists. I don't know, which I highly doubt, because I do know they're quite strict when it comes to knowing things, because people's lives are at stake. So let's see, I'm just looking for that video quickly, guys. It was done quite a while back. Yeah, so the big difference between pressure systems, thermodynamic system. Okay, there we go. Yeah, it's 4 minutes long. Let's see if I can get this up and going.
I have.
Okay, skip ads. Okay, let's see if I'm going to show it now. You guys ready? Okay. I think it's going to show. Okay, let's get it going. So no sound? Oh yeah, because I had a song on here. On all thermodynamic systems, I had a song on here, so they had to really take it down or something because of copyright or whatever. That was a while back, so I just took the sound out. Hope you're ready, as you are for a treat. Okay. Let's start off with open systems. What is an open system according to physics? Well, that's easy. The open system is when matter and energy pass through the system, like this glass of milk. Now we can explain a closed system. It does not let matter energy pass through its boundaries because it's closed.
Okay, right, cool. That's easy. I did 18 months of thermodynamics in my degree, so I know quite a lot about thermodynamics. So Earth is classed as a closed system in physics.
That's not true, because you can't have astronauts leaving them.
Yeah, a closed system in physics allows for the transfer of small parts of matter and energy. It's not completely isolated like an isolated system. It allows for some transfer of energy between systems. Whereas obviously an open system and isolated system are the other ends of those. So when we're talking about systems, the Earth is classed as a closed system, and the universe is the only isolated system that there is. And I will agree with you that the entropy of an isolated system will always.
Okay, hi FTFE, I see you are still trying to state that the closed system allow for matter to cross its boundaries. I think we just made it clear a closed system does not have any matter crossing boundaries. You do know physics states that closed systems do not allow matter to pass. We have debated this. FTFE comes. Yes, I was just thinking back on that debate. I will rather say nothing. Why? Because I say it's closed and that's final. You are just a moron. These are actual comments he made, people, by the way. Yeah. Oh, am I? Then why, according to every citation ever, it says I have what I have been saying? Which is common sense. Every citation shows closed system does not let matter through its boundaries. No, you're just wrong. Here's a citation showing I'm right. Okay, let's see this then.
Okay.
This is the citation, people.
Great, this is your citation. Why is Earth a closed system? Okay, even they say Earth is closed. Let's see what they say. Showing a box. Okay, recommended. A closed system. What do you think when you hear the word closed? Do you think of a closed door or a closed box? Well, if you thought of a closed box, then you aren't too far away from the definition of a closed system. By definition, a closed system is a system in which the only thing that can be transferred with its surroundings is energy, not matter, Craig. A sealed box is a perfect example of a closed system. Nothing that's contained within can come out, and nothing on the outside can come in. However, if, example, to heat up, turn up the box, setting a surroundings, the energy can release. What do they say here? The Earth. You may not think of Earth as a closed box. After all, you hear the astronauts going into space and even walking on the moon. But in fact, it is closed. Because virtually all matter, things that have mass and take up space inside the Earth's atmosphere, is kept inside as long as it follows Earth's physical laws. So in other words, it's saying it is closed, but it's not closed at the same time because I believe the Earth is a ball. And it even says it has to violate the laws of Earth.
So it says what a closed system is, which is closed, doesn't let any matter in, and that's Earth is closed, but can't think of Earth as closed. Kind of contradictory, you know, sort of like with gravity and gas pressure. Why does everything that has to do with the globe is contradictory to one another? Really weird, eh? So explain how is Earth closed and open at the same time, Craig? You hear? Nope. He just left. Thank you for watching. Great. I think I made that very clear. They don't understand. Hey, Mr. Scholar, good to see you. Thanks for coming. Shabda Sound, good to see you. Glad you could make it. And Flat Sabbath, yeah, you guys all rock. Thank you for coming. Let's get back to the poll quickly. Do you like comment reaction videos? 30 votes, guys, really cool. Yes, 73%, which is cool. No, 7%. And it's okay, 20%. I'm taking the no as the 7% of the Globers who are showing to be embarrassed here. Yes, please do hit that like button. Thank you, Mr. Scholar. If you guys haven't already, just hit that like button, yeah. Thank you once again, Aaron, for your super chat, Aaron Armstrong, and to Godzilla. Oh, Aaron Armstrong, you brought another super chat. Thank you very much. Can you definitely hang a plumb bob on a slope and there be no horizontal anywhere visible? Don't be silly. No, it's... Okay, you already read that one out. But yeah, thanks Godzilla. Thank you Aaron Armstrong both for your super chats. You guys rock. Yes, Mr. Scholar, I also voted yes if I could vote. For sure. Okay, I think let's get on to some comments because there's still quite a few to go. See if it's showing up. And it is showing. Okay. Mercator. At Plato's perspective. Because the co-altitude angle is the change of orientation of the ground. relative to the GP. No, it's not. A co-altitude angle is what's left over from a 90-degree angle. So, how can I put it? If you have your zenith, 90 degrees, and you have the horizontal, the 180-degree baseline, or 0. When you're making that reading, let's say 45 degrees, your co-altitude angle is what's left of the 90. So you have to take that and minus the 90. A 90 is not a curve. So that contradicts what a 90 is if you're saying it's the orientation of the ground. And what happened to you guys saying it's nothing to do with the ground? Yeah. On a sphere, there is a linear relationship between degrees and surface, distance and not on a plane. It's Euclidean geometry, darling. You know, when you base it on Euclidean, it's not spherical then, because then you can't have your sphere, because the linear relationship, darling, because of Euclidean, it's the measured arc. Remember I showed you the sextant, that arc reading? That linear arc relationship is the linear arc relationship to the sky arc, to the celestial sphere. Perspective, reading, aka gives you your linear distance on a flat horizontal plane. That's how it works. And there's absolutely nothing you do about it. Exactly, there's nothing you can do about it. You can claim your belief in a sphere all you want. You made that measurement on a flat baseline. Professor Phil Bell. Perspective, drawing triangles is not doing trigonometry. Since when is right triangles not trigonometry, Phil Bell? For a professor, you sure are spiraling. Let's see, right triangles. Trig. Right triangles in trigonometry. Kind of looks to be trigonometry. A right triangle of right angle triangle is more formally the orthogonal triangle, formerly called the rectangle triangle. Rectangled triangle. Why? Because it's actually based on rectangle. Triangle, which is one angle, is right angle and two sides perpendicular. So that would be a basis for trigonometry. How easy it is to debunk these guys, it's not even funny. And as far as we know, Sextant uses trigonometry. Let me see if I can find that quickly. Ooh, where's it going now? I'm just quickly looking for I think there's a education lesson. This could be quite interesting. Oh, there's a train. Okay, let's get you getting it right. Oh man. Okay, getting it right. Unit topic, navigation. Grade level, 7th grade. Okay, whatever. Lesson topic, calculation. Approximation. Geometry. Trigonometry. What do we always get told by the globe anti-flat earth side? You don't use trigonometry when doing celestial navigation. Institute of Navigation is wrong then. McToon. Institute of Navigation is wrong then. Ruhuf. Okay, anyway, that's just in the lesson abstract now. In this lesson, students will investigate error, as shown in earlier activities. Without understanding how errors can affect your position, you cannot navigate well. Remember this, come. You first measure your angle, then you have your corrections. Why? To make it more accurate based on a flat baseline. You make corrections because you look in 3D space and you always have optical effects like perspective and your incident angle because you have a height above the ground. Okay, we learned about computers, whatever. I don't think we need to read everything just to get that on. Opening topics, how to close or close enough, navigation, math and computers, things to remember when using computers, predict, hypothesize, project, use protractors to measure angles. How does a protractor work, guys? Would that be a 180-degree flat baseline to read the arc reading? Yeah, okay. Let's see, we're going on. It's going on, it's just... You guys can actually just go and look this up yourself if you wanted to. What is this about? A dartboard is a common example showing the difference between accuracy and precision. See dartboard diagrams. Let's say that someone throws 4 darts at a dartboard. If they are far apart, the unevenly spaced, they have no precision or accuracy, obviously, which makes sense. So it's going to be not very accurate, more accurate. Now, to have it the most accurate and precise, it's at the bullseye altogether. Makes sense. Good analogy. So, accuracy of measurement in navigation depends very much on the situation. If a sailor's target is an island 200 kilometers wide, being off by 10 or 20 kilometers is no problem because you're still going to hit into it. But if the island were only 1 kilometer wide, it would be missed if off the center at all. Yeah, because I mean, if it's smaller, and you're deviating, you're just going to be further and further away when traveling long distances. Okay. How to use a sextant? Does that line say horizon? Is that a horizontal line, people? Is that perpendicular to vertical, and is it parallel to that? The sextant is a complex device. It seems to be very complex for the globe defenders, by the way. But luckily it's very easy to use. Very, as you can see. Basically a sextant measures the angle between 2 objects. Remember, between 2 objects. With at least one being celestial. Obviously the star, this is why you have celestial navigation. Remember, never look directly at the sun. Obviously you have to put shields, you're going to get blind if you don't. The user looks through an eyepiece and after adjustment sees both objects superimposed onto each other. The measurement of the angle is then taken through the use of the 2 mirrors. The user looks through the sextant's eyepiece directly at the first object, usually the horizon. So they're literally looking at the horizon. They're creating a what? A parallel to the horizon. They are perpendicular, their zenith is perpendicular to the horizon. So they're using the horizon. The horizon is your baseline. Is your horizon physical or optical? Obviously it's an optical apparent position on a physical surface, on a horizontal plane. I mean, I don't even need to go further than this because this already debunks the whole globe argument. Anyway, let's carry on. There is actually a mirror in the line of sight, but because it's only partially silver, the can see beyond it to the horizon. The other mirror is connected to a movable arm, that's that index arm, because it has to move the arm so you can see and align them to touch the horizon. And then obviously you get your time from GMT. I'll be back in 2 seconds. My son just woke up, I gotta give him coffee. Children. Yeah. Okay. And that's getting the longitude. I hope you guys are just reading through it. Not really much. You can Oh, let's just read this quickly. This is quite interesting. Lesson vocabulary list. Geometry, the mathematical relationship of points, lines, angles, and surfaces and solids. Trigonometry, the things you guys say we do not use this lesson again. The mathematical relationship between the sides and the angles of triangles. Now, why would they put this in if we don't use triangles for celestial navigation? Sextant, a navigational instrument containing a graduated 60-degree arc. You first require 180 degrees. We know the internal sum has to be 180 for a triangle. Then you have your 90, which is your zenith, and then obviously the 60 comes because of the graduated arc of the sextant. So, what do we have? Baseline 180 degrees. You at 90 degrees, the sextant 60-degree arc. 180, 90, 60. You cannot have your 60 if you don't have the 90. You cannot have the 90 if you don't have the 180. And you cannot, that's how it works. Okay. Ooh, what does it say about altitude? This altitude, the angle between 2 points for horizon on the ground and the sun. Let that sink in. The angle between 2 points. For example, the angle between the horizon and the ground. The horizon on the ground and the sun. So that means the horizon is used for celestial navigation, is it not? That's what they teach the people. Let's go on. This is actually very self-explanatory, guys. I don't know how we get the people in the anti-flat earth side. They just don't get this. It's so simple. See, working out trigonometry. You're working out the triangle, a 90-degree right triangle. So your adjacent cannot be curved. You cannot have a curved horizon, a curved adjacent, because you are having a triangle. Wow, I mean, this is basic stuff, people. Come on. Make sure the baseline is at least 8 meters. Okay, this is probably a horizontal, what's the name? Because you can also use the sextant for horizontal based readings. Yes, so there we go. See, like they're using a protractor. They have the cylinders, obviously this starting point, and the protractor they're holding like this. You can also use that. And even for that you require horizontal, because if it was curved underneath, you cannot get your baseline. That was a horizontal reading, 600 kilometers, because you have to work out your line of position, how you're going to travel. Going on, yes, somewhat astronomical. I like this. Ooh, rocket ship to the moon. Yeah, it doesn't matter. Just violate natural law. Second law of thermodynamics. It doesn't matter. Just let's say we're taking a rocket ship to the moon. That's fine. Amazing how they want to take this. I don't know if this actually reminds me, because you have a circle of equal altitude. How do you have it as a triangle if you are claiming it's sphered? Because then it's not going to be triangles. But you are working out triangles with trigonometry. Just have to point it out to you. And if you haven't watched already, please do go watch Nathan Oakley's presentation with Brian Logic about circle of equal altitude, and how your surface area of the globe is too small to have even 2 circle of equal altitudes together. The surface is too small, means your globe is too small to even do celestial navigation based on circle of equal altitude. Definitely go and watch it, it's worth it. See, we go. The dip correction is 1.75 because of the height, because you are height, your eyes are above. You're not, the eyes in the sextant is not planted in the ground. That's how you get it. And that is all about it, yeah. And this is can probably showing this. You see, because what's happening here? You set your parallel to the horizon. The height above the sea is 2 meters. There. So you're making this now sitting there after you've done your height of eye correction. That's why you got the dip. They must subtract the dip of the C angle is da degrees. Why? Because it's 2 meters above. That eyepiece is not situated there. So you have to make correction for that so you have a more accurate reading. Because you measured this, and that's why you get a co-altitude reading to get your distance. Simple. So when somebody says dip correction, it's just them showing they are an idiot and ignorant to understand your eye is not embedded in the ground. Very simple stuff, guys. Hey Ruth, good to see you. Let's see, who else is here? Citizen Z, yeah, you guys are still here. Good to see you guys. Thank you for coming. Ruth in, oh, there's Ruth. Oh, you're still server muted. Sorry, dude. There we go. How are you doing? Haven't spoken since you last got triggered and left. Hello? So how's it going?
Lovely. I was going to say, you're talking a lot about celestial navigation. But
Yeah.
there's no doing of celestial navigation.
Sorry, I'm talking a lot about celestial navigation, but there's no doing of celestial navigation.
Yes.
I'm sitting in front of a phone. How am I going to be doing celestial navigation in the broad daylight without a sextant?
Well, either I can give you some angles, or you can use your phone app to take some angles. Either's fine with me.
I'm not here to be doing celestial navigation. The stream is about reacting to comments. You have to wait when I do McToon's challenge, which is going to be soon. I've just been very busy lately. Hey Scott, good to see you. Hey Anrama, thank you for coming. So, if you want to do celestial navigation, go ahead, because the basis still stands. You need a horizontal baseline.
Right.
And
What's the punchline?
it's measured flat, and then you make corrections, and then you set your globe.
Sorry, the Earth is measured flat, or the horizontal baseline is flat?
Everything is measured flat.
Well, the horizontal.
As far as I know, you also had a problem with Brian's logics working out on the Earth's surface is too small.
Yes. He thinks the well, first of all, the whole thing is kind of pointless, right? But is the area of a circle on a spherical surface is not pi r squared.
Okay, go on.
It's just not.
Okay, go on.
I'll have to look up the actual formula, but it's not that. And if you do it correctly, the biggest circle of equal altitude you can have turns out to be half the surface area of a sphere.
So 5,400
Obviously
nautical.
what you'd expect.
So 10,800 nautical miles.
As the diameter of that circle
Yeah.
on a spherical surface, yeah.
Interesting. I'd like to see you can actually do it and debunk him, because as far as I know, they did use the right math.
They did not use. No, he just went 5,400 times, pi r squared. And that's not the area of a circle when it's on a spherical surface.
Okay. So you'll be able to do a video showing the right math.
Oh yeah, I'd honestly have to Google the correct formula or derive it, but it's not pi r squared.
Okay.
But even then, like his logic was 3 circles can't fit on the Earth, which is just silly because circles of equal altitude overlap. They're not cumulative like that. They overlap necessarily.
I agree, they do overlap because it's your position point to the 3 different altitude, well, circle with altitude angles. Because they have different altitude angles, it gives different distances. But he was taking it as maximums.
Necessarily overlap. Where's an example? Can't find one.
So yeah, while you're busy looking there, hi, Gary Wybenga, good to see you. Thank you for coming in. Yeah, we're doing a reactions video. Do you like comic reaction videos? out of 33 votes. Yes, 70%. No, 9%. It's okay, 21%. Why do we always have this Mason 33 everywhere? Okay. So yeah, Ruth. So I'm just going to say thank you for coming, but we're not really going to talk right now because I'm still doing the reaction video. But thanks, but I'll definitely look forward to the video with the actual math. And then, like I said, I am still going to do McToon's challenge with your 4 questions.
You want me to drop or do you want me to hang around?
You can hang, but it's just not going to help to talk there because I'm doing the commentary. Okay, thanks. Cheers. Hey Scott, thank you for coming. Yeah, remember, just like I told you, if we're just having the a commentary, so it's not really going to help to comment right now. Thanks for coming in. Okay, let's get on to the show. Hello, Eli. Is it showing? Yes, it is showing. Okay. Tom from America. Atlas's perspective. No, we are not measuring the sky arc. Then what are we looking at? Are we not looking in the sky? We are measuring an elevation angle. Yes, elevation angle means you are measuring in the sky. You're measuring on a horizontal plane in the sky. That means measuring to a sky arc. Nautical miles are not square miles. Yes, they are. That's how a nautical mile was derived, because it's an arc measurement over a distance. So you guys are saying it's over the ground after you've taken the measurement to the sky. The arc in the sky is not 60 nautical miles per degree in length, rather the distance from the GP to the OP across the surface. This is 60 nautical miles per degree, the zenith angle. This is the definition of nautical miles. Would you like to update the definition in some way to make it fun and reliable to work on a flat earth? Okay, how am I going to explain this? When you show the sextant, I wonder if they got a picture of it here. Eli, Mama up here. Okay, here's a sextant. You see this arc here. That arc is the arc measurement of what you're seeing in the sky. So because you got parallel rays and perpendicular rays, they have to be measuring. So what you're measuring in the sky is going and measuring onto that arc, into that arm. Because it's measuring onto that arm, that is where you get your 60 degrees nautical mile. And that is the surface of degree measurement. Because it's measured on a horizontal baseline, you're getting your altitude angle, your apparent altitude angle. That apparent altitude angle is the same as the arc's altitude angle. That's the reading you're getting. So what is it creating? It's creating the linear relationship. Sky arc to that to give your distance. That's why you have your micrometer with the minutes of reading as well. Yeah. Let's see. Okay, I see Sean Hawkins is still here. Let's go on to reading some more comments. It's going to be a bit difficult now because, as you can hear, all the children and everything is awake now, so it makes it a bit difficult. Is it showing? Yes, okay. There is no actual bulge. I agree, there's no actual bulge. The rise is gradual from the poles to the equator. So you say there's no actual bulge, but you're saying there's a rise. So that means there is a bulge. You already contradicted yourself. No curving of space-time applies. 100% agree, because space-time is just a concept. Everywhere is the same mass. What has mass and gravity got to do with now a bulge and gravity? This doesn't make sense, but okay. Yeah, gravity doesn't exist and there's no bulge. 100% agree. Remember, I showed you how we get the nautical miles on a flat baseline. Yeah, very, very interesting comment there. Next, from Blogger. That's not the definition of a circle of equal altitude. You have it backwards. It's not the arc of the things you can see from a given position. It's the set of positions that can observe a single object at the same altitude. Yes, the same altitude, Blogger. That's the whole point on the arc of the circle on the horizontal baseline, the GP of the star is on the same horizontal baseline as the GP which you are taking the measurement. So it falls on the arc. That 90-degree angle is the arc's limit to you. That's why you have circles overlapping to each other, because they're touching that arcs at the same altitude. So they have the same altitude, you understand? Not having different altitudes, same altitude on the horizontal plane. If it was different, it wouldn't work. Duncan McNeil. No, the measurement is to the GP of the star. No shit, Sherlock. Which is the distance along the ground or sea. Yes, which we just explained. 100% agree. The distance comes from the arc measurement, the apparent altitude angle measurement. And that degrees come to 60 nautical miles per degree. Ah, yes. Because 1 degree is 1 minute of arc. That's how it works. The whole point of celestial navigation is that the distance on the ground is proportional to the co-altitude of elevation. This doesn't happen on a flat plane. Unfortunately, Duncan, you took that measurement on a flat plane. That's why you have an elevation angle. That's how you have a co-altitude angle. Remember, what's a co-altitude angle? It's the rest of the 90-degree measurement. So, if I measured 30 degrees, and I measured a 30 degree in the sky, it's 90, so you minus 30 from 90, you get the 60-degree co-altitude angle. And then how do you get your distance? Because it's 1 minute, you just times it by 60, and then you get your distance. Mercator, elevation angle already specifies that is an angle above the horizontal plane. Thank you guys. It's an angle above the horizontal plane. We can all go home now. Adding horizontal has no meaning and increases confusion. You just told us elevation angle already specifies that is an angle above the horizontal plane. So adding horizontal has no meaning. Do you just see what you did here? You're telling us it's a horizontal plane and then telling us adding horizontal has no meaning. Ooh-wee. Oh man, James D, good to see you. Thank you for coming. Yes, James D. Angles require 2 straight lines. No angles from a curve based on 100% agree. Hey, Paul P, good to see you. When are you going to do McToon's challenge? When I do have time, Paul, because it takes time to do that stuff. Like I said, I've been having a very busy past few weeks with my daughter's ballet recitals and her choir things. She's now in the finals with the choir, which is in 2 weeks' time. Next week, now is a birthday party. I'm having family over for the whole week. And yeah, and she's turning 7 tomorrow. So yeah, she's definitely, I'm having a very busy time, and with all the live streams and things, definitely. Also, guys, hook me up if you want to have another live stream in a week. Do let me know. So yes, I'm going to do McToon's challenge. Just be patient, please. I have a life outside of YouTube too, because I don't know why, but it seems the globe defenders or anti-flat earthers have some kind of outlook on flat earthers that we do not have a social life, which is totally against reality. Hey Kevlar, good to see you. Thank you for being here. I want to say happy birthday. She says thank you. Yeah, let's go on with some comments. This is Zach. Are you guys at least enjoying the comments so far? Because so I don't know, man. Unfortunately, I can't show that comment. Quite vulgar language. Yeah, so it's good to see you guys. I hope you're enjoying this comment sections, because I'm enjoying it, I have to say. Let's see if it's showing. Okay, it's showing. Which one is it? Okay, let's move on to this one. Mercator. Any marine sextant reading is an escamotage for measuring Eratosthenes' angle of co-altitude. Thank you for providing the basis that Eratosthenes proved it was flat, because a co-altitude angle is a measurement of a flat baseline. So when you're saying it's the Eratosthenes angle measurement, the co-altitude angle, you are actually conceding he took a flat based measurement. In other words, not parallel sunrise, divergent sun rays, giving us the angles needed to have the co-altitude angle, which is a flat baseline. You just debunked your whole globe there. Just because you cannot use a plumb bob or a bubble level, you have to resort to measuring an elevation angle using the horizon. You can use a plumb bob, and I've seen people use plumb bobs still with the sextant. I mean, you get a lot of people that do use plumb bobs while they use the sextant at sea. So I don't know what you're trying to say there, but like I said, bubble level, you still have to create your horizontal. That's what elevation angle comes from, off the horizontal. The horizon is the second class reference. No, remember in what we read there? On that, yeah, it was, yeah, you know what we read on that, this navigation or whatever? The horizons, to the actual horizon. And with this, we read it to the actual horizon. It's not secondary reference, it means when you're doing a marine sextant, you're looking out. That's why they create the artificial horizon if they can't see the horizon. And needs to be corrected for edging out the curvature of Earth and refraction of air. No, those corrections are made because your eyes are not embedded in the ground, so you have a height of eye correction. You can have, doesn't matter what surface you're standing on, it can be a donut for all I care, it can be a triangle. Your eyes will always be above that, and you have to make the correction for the horizon you're looking at. That's why when they brought up the house roof, that is the apparent horizon you're looking at, because according to perspective, the horizon always rises relative to eye level, and it's the apparent position where the sky and the ground appear to meet. So a roof of a building is an apparent position where the sky and the ground appear to meet. Okay, when you found approximately the horizontal plane, yes, you can subtract the measured angle from 90. So you have a horizontal plane and a zenith. To obtain the only angle you need, the co-altitude angle, the Eratosthenes angle. Thank you, making my point. Eratosthenes then used flat geometry, Euclidean geometry. He used a flat baseline, so not the globe then, that measured the change of your ground's orientation. No, he measured the apparent altitude change. The ground didn't change. Remember, he measured from a horizontal baseline. Horizontal does not change. Just the altitude angle change, apparent altitude angle. Remember, that's why I showed you my my graph where it changes with apparent altitude. Really weird. Conspiracy cats. At 5 minutes 6 seconds, you said that the zenith was the altitude. No, zenith is an imaginary point directly above your location. Zenith has altitude. The zenith is the vertical measurement, so that's the relationship for your altitude. It has to follow the zenith and has to follow your horizontal. That's why zenith is based with altitude. If you did not have a zenith, you cannot have an altitude angle measurement. If you don't have a horizontal, you cannot have an altitude angular measurement because it has to follow the horizontal. Martin Smith. Flat switch perspective. Trigonometry is the study of the relationship between the sides of angles and triangles, and not right triangle. What's this? Is that a right triangle? Is that trigonometry? What did you say? The study of relation between the sides of angles of triangles and not right triangle. A right triangle is a triangle. You dipshit, it's trigonometry. Okay. Mike O'Barr. We never said the angle and the latitude aren't linked. What we said is that if you go stand on the 40th parallel Polaris, isn't at 40 degrees on a flat Earth, but it is on a globe. That's quite rubbish. Your graph shows everyone looking at different stars at the latitude. Lines get closer together towards the equator. Let me just first go back there maybe, and then I can do this. This is what I show people just for your information, because these guys just don't get it. Okay, let's just take it from here, it's fine. He said 40 degrees. So Mike at 3,000 nautical miles did not measure a 40-degree apparent altitude angle. That is a right triangle on a flat baseline. Flat Earth, 40 degrees. If you stand on a flat Earth, you do not measure 40 degrees. There we go, we just measured 40 degrees. You cannot do it on the globe, however. Why? Because this baseline would be curved and you cannot have an angular measurement. That's why you guys first take this measurements, the flat measurements, and then duplicate it to the center of your globe. Yeah, don't have it on this one, but on the next one. But anyway, you get what I'm talking about. So definitely you have no clue what you're talking about, Michael Ball. This is okay, that is that one. Okay. Conspiracy Cats again. And yes, Culture Cats is Conspiracy Cats. He has like 3 or 4 accounts that come and troll me. This is supposed to be a teacher, people. A teacher that's supposed to be honest and comes with different accounts to troll my channel. And then has the audacity to tell me my channel is stagnant and dying while I'm having quite considerable. As far as I know, that's not looking like it's dying, is it? It's 59% gone up, 17% gone up, 85% gone up, 4.6k in the last. It's doing much better, so definitely not dying. Thanks, cats. Yes, I'm 100% saying that the distance from Polaris, okay, to Earth does not change because an observer decides to move. Do you guys catch what this guy just said? This is a teacher, everyone, a teacher. Yes, I am 100% saying that the distance from Polaris to Earth does not change just because an observer decides to move. Okay, so he's saying the distance to Polaris doesn't move. Obviously, read it wrong, it would be the distance because it's got a physical distance. But your altitude angle changes, your distance to Polaris changes, so therefore it makes a distance change to the GP, because that's how it works with celestial navigation. Why the fuck would a star millions of miles away decide to suddenly move? Who said it's millions of miles away? That's you making that claim that it's millions of miles away, and you can't measure it millions of miles away because you measure it on a flat baseline. Just because somebody, the Earth, moved closer to the equator, this is just you having a fundamental having problems understanding fundamentals when it comes to measuring apparent altitude angles. At different angle measurements, the apparent altitude changes of the star. It's not physically changing, it's apparent because we live in 3-dimensional reality. You are measuring at 30 degrees, it is 30 degrees. To get that 30 degrees, you actually physically have to walk along that horizontal plane to get that angle measurement. That's how it works in reality. Okay, it's not millions of miles away. If you want to do that, take a horizontal baseline, do your measurement and show how it's a million miles away. And please, please use a flat baseline because that's what you're measuring it from. Don't go and duplicate the layer to the sphere Earth in the middle of your sphere Earth because you have a belief. If you measured flat horizontally, you did not measure any curve. There's no curve measured here. Only curves measured is your arc of the sky. That's it. Your linear distance comes from this. Linear distance comes from the sextant. Where is it now? Okay, now. What's the other one? Anyway. The linear distance comes from that arc and the arc on your sextant. Why? Because they mirror each other to give you a 360 degree. Okay. So, you do not understand this challenge at all. You are pumping content out there. So that's what he gets. Instead of saying why, he just says you do not understand after making a very, very Nike, I believe, after making a very, very bold claim of the stars being millions of miles away by using flat measurements. Barton Smith. On a flat plane with Polaris, some distance above the center. No matter how far you moved away from the center, the star would never have an elevation angle of 0. Martin Smith, I take it to you. If you go stand on the equator, do you measure a 0-degree angle? Do you measure that 0-degree angle if you go stand on the equator? In reality, yes, Martin. Did I show this on a flat baseline? Yes, Martin. Your apparent altitude angle drops with distance. It converges into the horizon. It's an optical effect. Do you understand? Excuse me, guys. Give me 2 seconds. Sorry about that. Just trying to get the children because all I hear is them, and I'm not sure if they, if that's all you guys can hear instead of me. Yeah. Very plain and simple. You do get the 0-degree because we measure it in reality and we measure it from a horizontal baseline, Martin. That's how it works with reality. Wow. Teacher or preacher? Exactly, Anrama. I would say more of a preacher than a teacher. Rory Williams, good to see you. Rory Williams. If information that's presented doesn't fall within people's belief system, they will fight tooth and nail to keep themselves in their belief. 100% agree, Rory. The globe is based on the belief system, so they have to fight to keep that belief system because, well, it's a belief system. Oh, I'm actually glad I moved the, if you can see, I've got a different background. I've actually changed now today because yesterday I was having the live stream and the sun was rising and coming at the back. So as the sun gets closer, it's just lighting up the background. You can't see me. So now I've done a 180 degree. Yes, 180 degree borders. So the lighting is much better, I must say. Paul P. It's not millions of miles away, but I have no idea how far away it is myself. Great, Paul P. You're getting somewhere. Conspiracy Cats did make that claim that it's millions of miles away while having a flat baseline measurement. Okay, Kevlar, yeah. I'm glad you guys aren't bothered with me, but I'm a bit bothered with it because I want to have it a bit more professional. It's difficult with the children though. But as you can see, flat earthers have a life. We have children, we have families, we have social lives. So every time you hear someone saying flat earthers are dumb, they don't have social lives, they're sitting in a basement, is obviously just very delusional. Yeah, so it's good Paul P, that you agree that the sun isn't, the stars are not millions of miles away and you don't know. 100% agree, that's what we all say. You don't know because it's an apparent altitude angular measurement. You'll never know what the actual distance is. Okay. Again, thank you Aaron Armstrong for all your super chats. Really do appreciate it. And Godzilla37, thank you once again for your guys' super chats. You guys rock. Really do appreciate it. Okay, let's get on to the next. Okay, again, the teacher. That's supposed to be not a troll. I just want to ask one thing, Conspiracy Cats. Remember you made a comment. I wonder if I can find it. This was Conspiracy Cats a while back because he's now ignoring this. Because apparently he's brought a textbook out or bringing a textbook out to something that is telling gas pressure doesn't require containment. But as far as I know, he had some video saying it does require containment. So he's ignoring me when I say, please show me. Does it require? I think it's this one. He cannot. Ah, it's this one here. Day of the intros. The day of the intros in.
Earth are Now this flat earther has been, how can I put it, totally useless in every aspect of every bit of content he's been putting out recently. I think that about sums him up. I mean, for example, there was this video in which you called me a liar.
Conspiracy Cats is dishonest.
Told you. But
Yeah.
I let the fact that he called me a liar go because I know deep down he's just confused.
Why is Conspiracy Cat so dishonest, you ask? Well, I'm going to have a few comments on his YouTube channel, and maybe you deduce for yourself.
Look how little subscribers I had that time.
An actual liar, because he cannot back up his assertion for his globe. Well, sit back and enjoy.
Now, what Nathan is saying is you can't have pressure without containment.
Now, in a way, and only in a very small way, he could be determined to be right, because without something for the particles to be striking, you're not going to get that change of momentum. But that doesn't mean that there has to be a dome. All that means is I just take the balloon away. Without the balloon, these air particles aren't going to be striking anything. Therefore, there is no pressure.
Did you guys hear that? Without the... So, he contradicts himself in like a span of a minute. Let's listen to that again.
Because without something for the particles to be striking, you're not going to get that change of momentum. But that doesn't mean that there has to be a dome. All that means is I just take the balloon away. Without the balloon, these air particles aren't going to be striking anything. Therefore, there is no pressure.
Again?
Without the balloon, these air particles aren't going to be striking anything. Therefore, there is no pressure.
But then there was this.
Conspiracy Cats is making false claims. Oh, what a dishonest man.
And I'll let that go also, because even though he's claiming again that I'm somehow making things up and I'm a liar, I know deep down that he's confused.
Yeah. It's very simple, guys. He says you don't need containment, but you do need it because you need collisions to have the pressure. In the same sentence. Take away the balloon, you still have the pressure. Exactly, Kevlar, because it's in the system. The balloon is a system, it's inside a separate system. So pop the balloon, the pressure that was inside that system, it disperses into the existing system. No balloon, no system, no pressure. It's just dispersed into the surrounding system. Yes, jack of all trades. Gas molecules can strike other gas molecules, but let's put it this way. This is just very simplified. This one is going, it hits, it bounces off that way. Is that gas particle that gone off that way, is it ever going to come back to give gas pressure again? No, because it's going to disperse into the surrounding area. It's just never going to return. Because that's how gas works. Gas never ever loses all its energy, as Professor Phil wants to make you believe. Why? Because gas cannot stop moving. Gravity has no direction on the direction of gas. It has no effect on the direction of gas. I keep showing this to you guys. Yes, jack of all trades, gas pressure. Like I said, if it hits another gas particle, it would be gone, and there wouldn't be gas pressure to breathe, because it will only hit it once and disperse into the vacuumless void, and you would never ever see that gas particle or mole again, whatever. It's going to be gone. Do you understand that? It's called entropy. It's going to go and spread out. It's going to have more disorder. It's a very simple basic fundamentals, this. Gas pressure is real, exactly, Kevlar. And you require containment to have gas pressure. Why? Because we are breathing. The gas is returning to us to breathe. We have a fluctuation of gas gradients based in containment. We live in a dynamic system. Gas can only hit once, that's oversimplified. Yes. If it wasn't contained, it can only hit once and move direction. Gas can only change direction when it hits another surface. You get it? So if it hits and it bounces away, it's never going to return again if it doesn't hit something to come back. It's like an explosion. If something explodes outwards, if there's nothing containing it, let's say when they have to defuse a bomb, they stick a dome, an iron dome around it in case it explodes. If that explodes, it hits that iron dome, correct? Yes. It hits the iron dome, so the shrapnel and stuff will hit it, and what happens? It will bounce back because it actually hit against the walls of that dome container. If there's no dome container, what happens? The explosion just goes and disperses out. It will never return to that position. The same with gas particles. If it hits a gas particle, the surface or whatever, bounces away, never return again. So you need containment to have that gas pressure in the first place, because that's what gas pressure is. It's the gas exerting a force on its container walls. Pressure gradients come after containment. First require gas pressure to have pressure gradients. That's it, guys. As simple as that. RH, a tornado. Yes, in the same system. Great. Low pressure system with a high pressure system in the same system. It's a dynamic system. Moving gases. Conspiracy cats. Do a video on the random walk of gas particles. Okay, I can do that for you if you really want to. So, Conspiracy Cats, will you please answer me, since I've asked you, I think it's like 8 times this week. Will you be putting that in your textbook? Without the balloon, there can be no pressure. I did ask you this a few times, it's just ignoring it. But good to see you, Conspiracy Cats. Thank you for being here. And it's almost time to close off. So let's see if we can maybe get another comment or two in. Okay. I think it's showing. Yes. Okay. Tom from America. What are apparent angular measurements? Are they different from angular measurements in some magical way? How do I put this? When you look with your eyes or your phone or theodolite or scope or whatever, you are looking through three-dimensional reality. Everything has an apparent location. Every apparent location is a different angular measurement. That's why the stars appear to be at different altitude angles, because a 30-degree apparent altitude angle is a measured 30 degree. It's not going to be the same as a measured 80 degree. They are two different angular measurements. Apparent altitude angle measurement, because you're actually apparently measuring them at that altitude angle. Capiche? No magic. Donald, those are not all 600 nautical miles along the ground. Yes, they are. This was just to try and show you the relationship based on perspective, how they compress in the distance and compress, because that's how it works. Remember, I'm telling you it's got a linear relationship. Why? Because this arc has a linear relationship to what arc? The sextant's arc reading. That's why you have your linear relationship, because you took a baseline measurement. Sorry. Remember this?
You might have seen videos like this before.
Okay. Let me just... okay.
The difference between 90 degrees and the observed altitude of a celestial body is called co-altitude, or zenith distance. This is an important angle to remember when you begin to use celestial navigation to plot a line of position, because zenith distance can also be expressed in nautical miles on the surface of the Earth. Let's say you have obtained a sextant observation of 70 degrees on a star, measured along a meridian north or south 0 degrees to 90 degrees. The great circle distance of the arc along the Earth's surface is called arc distance.
That's that.
It can also be translated into linear distance, 80 degrees. The great circle distance of the arc along the Earth's surface is called arc distance. It can also be translated into linear distance.
Do you get it? So that arc and the arc of your sextant make the linear distance on that horizontal plane. Got it? Okay. Simple stuff, guys. Very, very simple stuff. Mic drop. But your bottom of the graph wasn't linear. I just explained to you, mic drop, that was taking the perspective into account, because I have to explain it. Even though the graphic isn't perspective based, I had to explain it in a perspective way to you guys, because you live in a 2-dimensional reality, not 3 dimensions. Yeah, the voiceover sounds like the Mission Impossible guy. The mission exactly, it does actually. Hey Akum Virus, thank you for joining. Yeah, you missed all the fun. We're about to actually stop. We can maybe still stick in another 1 or 2 comments. English can be translated into Chinese, therefore English and Chinese are similar. You just debunked your own argument there, Jack of all trades. English and Chinese are both languages. Just because I can translate English to Chinese doesn't mean I didn't say it in English first. This just means I've made the Chinese read out the English version. So you've just translated the information. Exactly. So when you take your flat horizontal baseline information, you are converting that apparent arc in the sky, celestial navigator, and the arc measurement on the sextant to have a linear distance, because a horizontal plane was measured. You use the horizontal plane to measure a sky arc and a horizontal arc on the sextant. Very simple. Yes, Andrew, the curve, not Earth curve, there's no such thing as Earth curve, creates a linear distance. It's the apparent arc measurement and the arc of the sextant. Let's see if I can bring up another picture of the sextant for you guys, because it seems to be very difficult to you guys to understand. This one might be good. This looks quite... Let's let the advert go past quickly. Sorry about my children in the background. Okay. So we should not be considered professional. Okay. Ooh, this is quite cool. I hope it's showing. Okay, it is showing. See, this is a sextant, people. If you're looking through it, this is how you're looking through it.
Tools behind the sextant and be able to label all the different parts. If you haven't already seen it.
So, you got the scope which you're looking through. You got the you got the mirrors, and you got the filters, obviously, and you got the mat where you got to hold it. You got your index arm going across the arc. This arc here is measuring the same as the arc in the sky.
So the guys going back and watching it.
Yes, this arc here, guys. This is why you have a linear relationship on your horizontal.
First.
Okay, so what happens? This is looking through here to where? To the horizon, which is parallel to this parallel of the arc. You get that? This is reading because you're perpendicular to that horizontal. That's why you have a linear relationship. This arc is parallel to the horizontal parallel, measuring the arc in the sky. Perspective arc. It's not a physical arc, it's a perspective based arc. It's an apparent altitude change. We showed when the stars have different angular measurements, they have an apparent drop. So that drop gives an arc shape due to our vision. And this has the arc measuring that arc. So that arc along the parallel gives you a linear distance. Do you understand now linear distance comes from the arc measured on the ground. That's your arc measurement on the ground, people. Because you're standing on the ground holding the sextant. It's like, I don't know how to make it more, how can I put it, dumbed down for these guys. Angles require straight lines. Exactly, Modern Lab. Thank you for coming. 100% agree. Don't know how we're going to get it to these guys that you measure angles, straight right angles. You measure using right triangles on a horizontal baseline. You then take that, and because you look in three-dimensional space, the apparent angular measurements based on the horizontal plane, you translate that into distance, which is based on the horizontal plane. Just because you have a belief of a globe and you take that measurement and duplicate it to a center of your presupposed Earth after you've taken the measurement, does not make it a sphere. It just means you're religious and you have a belief that you need to use flat to have globe. Remember, the have sign comes after the measurement, Sean. So yes, you do. Oh man, this is sad. Okay, anyway, thank you everybody for coming. Once again, thank you Aaron Armstrong for your super chats. I really do appreciate it. And thank you to Godzilla37 for your super chat. You guys really are awesome. Appreciate all the Patreon supporters on my channel. Without you guys' support, we wouldn't be able to be doing this. So once again, thank you everybody for everything you've been doing on the show. And see you all Wednesday. God bless.